we are talking about something new, polar graphs, okay? So you can actually already see some of the questions there. We're gonna flip back and forth around in this packet. Some of these things we're gonna change. And the thing is that up until now, you've been graphing X and Y coordinates left, right, up, and down. Well, today we're gonna talk about a new way of graphing, okay? So, previously, you graphed X, Y, horizontal, vertical. Now, we're going to graph R theta, where we saw those are different radii, and then at different angles, okay? Specifically, we are going to graph sines and cosines and lines and all sorts of other stuff like that. So, before, we graph y equals sine of x. And what that meant is, if you remember how we actually did that, we had x, and then we had sine of x, and we did 0, and then I said plug in 0, and we plotted that point, and then I said, 30 degrees, and we end up with 1/2, and then so we said 0, and then it was 1/2. And then it was like 45, and that was root 2 over 2, which is 0.7. So we plotted that dot, and then we continued down here, we ended up something kind of like that. Y'all remember? So that was how we plotted and graphed the sine function in rectangular coordinates. Today, we're going to do the same thing, but in polar coordinates. And spoiler alert, it doesn't look like that. Okay, I know. So what it does look like is something different. So here's what I need you to do. Turn the page. You're going to go to the bullseye page. It looks like this right here. And the first thing that you're going to do while I pull it is this degrees here, we're pretty much going to just wipe all that out. Okay, I put negatives there. I don't know why I had that negative. I think it was a leftover. So you just pretty much draw a line through all of that. And what I do want you to do is in this X column, okay, where I want you to put the radians, the radian equivalent of all those. So for instance, it says -30, but imagine it was +30. 0 would be 0. So here's degrees. What I want you to do is fill this out with radians, okay? So next to where it was the -30, we'll really slash that out. I want you to put pi over 6, okay? And then at the -45, this is really gonna be the 45. I want you to put pi over 4, because here in a minute we're gonna fill in all of those values. So if you need to pull out your trig chart, do that pi over 6, pi over 4, pi over 3, pi over 2, and so on and so forth, while I pull up the documentation over here.
Yeah, there was something.
And then go ahead and do that on the other column as well. Yep. Yes, if you go over there, Mr. Greensword can show you there's some on the shelf there. Mr. Greensword, she needs a trig chart.
Thank you.
grab your calculator, make sure you're in radian mode. Alright, so y'all help me out here. So pi over 4, pi over 3, pi over 2, call out what's next quadrant?
2 pi over 3, 3 pi over 4, 5 pi over 6.
That's good enough for us right now. Alright, so at the top of that column, go ahead and label that as theta. And then, I know this other one says y, but we're not going to do y. We're going to do, so this is y, you just kind of scratch that out. We're going to do r, so the radius is equal to the sine of theta. So r equals sine of theta. Alright, so what we're going to do is just going to kind of go down the line, and you're going to just type in sine of that angle, and then that's going to give us the radius. So make sure you're in radian mode, because we've got radians here. What is the sine of 0, class? 0. Okay? So let's go ahead and plot the point, 0 radius, 0 angle. I'll go ahead and plot it on this one right here. Right there. Now your circle, how many, or your diagram, how many different points how many circles do you have? 1, 2, 3, 4. I see 4 of them. So 1, 2, 3, 4. Okay, so for whatever reason, I cannot find that exact file that y'all have off top, just really quickly. So here's what we're gonna do. Go ahead and label. Well, I don't know if you need to label the whole thing. The second ring there, you can label that as 0.5. That's gonna be a 0.5 radius. And the fourth ring all the way out, let's put a 1 right there. That's gonna be 1 unit for you, okay? So what would that first ring be, radius-wise? Nope, this first ring. I mean, the first dot is obviously 0. A quarter, 2.25, okay? And then this is 0.5, then this is 0.75, and this is 1. Okay, so let's go pi over 6. So type in sine pi over 6, enter. 1/2? So 0.5. So I need to have, think about this is, what we're going to do now is we're going to plot the point, 0.5, comma, pi over 6. This is plotting points, that's what we did last week, right? So 0.5, so we're on the 0.5 circle, and the pi over 6 angle, so that's right there. This is looking like a strange graph indeed. Pi over 4, type in sine of pi over 4. Root 2 over 2. Now I need to know that as a decimal. 0.707? Oh, we'll just round it to 0.71. So the point that we're going to plot is 0.71 for the radius, and then pi over 4 on the angle. So 0.71, that's a little bit less than 0.75, okay? And 0.75 is this third circle out here. So I'm going to be on the pi over 4 line. All the way out here would be 0.75. Right, a little bit snug underneath it would be probably 0.71. So it's on that pi over 4 line, but then just a little bit inside of it. All right, pi over 3. What is the sine of pi over 3? 0.875. 0.87. Technically it's 0.8660, but yeah, 0.87. So almost like, you know, like a little bit less than 90%, maybe 87%. So on the pi over 3 line, so this is all the way out here on this fourth row would be the 100%. That's 75. So we're kind of in the middle, something kind of like that. Pi over 2. Sine pi over 2, enter. 1. So at the pi over 2 angle line, we're going to put a full dot right there. Two pi over 3. Sine of 2 pi over 3. 0.87, that's interesting. So we're plotting the point, plotting the coordinate 0.87 comma 2 pi over 3. So here's the 2 pi over 3 line. So 0.87 is going to be between the 75 and the, so something like, kind of like that. What is the sine of 3 pi over 4? 0.71, so a little bit underneath that 0.7 line. So at the 3 pi over 4, I'm going to be just inside there. What's the sine of 5 pi over 6? You guessed it, 0.5. And the sine of pi? 0. That's kind of a good place to pause. Let us connect the dots with a smooth curve. Ooh. That's interesting. Yeah, it's only oblong because yours truly isn't super accurate. It actually should be a circle, like a not oblong circle, an ob circle. All right. But we're only halfway there, class. We need to now start plotting, you know, the other quadrant. Okay. So, sounds good. Call out to me. Alright, so call out to me some radian angles. After pi, what comes next? Just the radians.
7 pi over 6.
7 pi over 6, keep going. 5 pi over 4, and 4 pi over 3, then 3 pi over 2, that's the 270. Alright, and then the fourth quadrant, go for it. 5 pi over 3, and? Keep going. And then 2 pi. Alright, here we go. So 7 pi over 6, and what is the sine of that angle? Negative 0.5. Okay. Now this is equal to our R value. So let's think about this. We're going to plot the coordinate negative 0.5 for our radius, and our theta is 7 pi over 6. This is why it's so great. Math builds upon itself and blah, 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 blah. Okay, last week we talked about plotting coordinates, right? And sometimes you have a negative R. Now when we had a negative R, what did we do? Find the positive, and then did the 180 thing, right? Okay, so the 7 pi over 6 line is right here, okay? So if I were to plot out 0.5, then that would be kicked out to this circle here. But if I go 180 degrees around the center here, that's going to put me right over there. That make sense? It's actually right back on top of that other point. What is the sine of 5 pi over 4, class? Negative 0.71. Wait, negative again? So that means, so I normally go down the 5 pi over 4 line, and so I'm out to here. But since it's a negative radius, I'm gonna go back over here, and it's gonna put me right there. Are you agreeing? Sorry, does that make sense? What about this next one? What's the sine of 4 pi over 3? Sine of 3 pi over 2? Sine of 5 pi over 3? Sine. Negative 0.71. Negative 0.5. And 0. So it looks like, as I'm going around that second and third quadrant, so to speak, I'm actually, the points that I'm plotting are right back there, so then I kind of do that number just like that. And that's not too surprising. We've seen graphs which repeat themselves before when we saw this. Up, down, back to center, up, down, back to center, the Y was repeating. Here we have situations where we go around, we go around that circle, then we go around, then we go around again, and as theta continues to increase, it's just going to go around the circle, round and round and round and round and round, which is kind of interesting. This formula is really easy. It's just r equals sine theta to get this circle. If we wanted to plot that in rectangular, I don't know if y'all ever mess with graphing circles in rectangular. It's really yucky. It's like x minus, it'd be x squared plus, this one would be y minus 1/2 squared equals 1 squared, which would just be 1. It's really, it's x minus h plus y minus k, and that's all squared, and then equals the radius squared. So, where h and k are the center. So anyway, you end up with something that's not really very friendly. That's kind of gross, but this one over here, r equals sine theta, it's a simple function. So this is one of the advantages of using polar coordinates is when it comes to circles, and as we'll see here in a minute, other patterns and things like that, you can get some really complex things with basic equations. What's more, if you remember your Algebra 2, this right here does not pass what we call the vertical line test. Okay? It's not a function. Okay? That causes problems later on in advanced mathematics when you're wanting everything to be a function. Okay? However, r equals sine theta is a function. Okay? So if you ever end up taking some more advanced math and you need things as functions, well, and you've got a graph that looks like that, just go with the polar on that. Okay? What I want you to do as a table is not sine theta, cosine theta. We're only going to do sine theta, cosine theta. Tangent is, I don't even know what tangent is, but maybe we'll do that later with the calculator. But go ahead and run through that same exercise. It should take you just about a minute or two. You've already got the radians. Type in cosine, cosine of that angle, cosine of this. Plot those points. You will notice a pattern again. .87.71.50. So,
Unfunded point 1 theta. That's what the first point's gonna be.
pi over 6. Alright. So class, if you look up here, I've got some of the points already marked off for my, my r equals cosine theta, my radius column. Check to see if you got the first 5. 1, then 0.87, then 0.71, then 0.5, then 0. Look right to y'all. So then as we start to graph those points, what this corresponds to is a radius of 1 and an angle of 0. So that's going to be right here, radius of 1 at the angle of 0. Then this point right here, a radius of 0.87 at the angle of pi over 6. So at the pi over 6 line, we've got a radius of 0.87. So we're going to go farther out than the third line, you know, kind of halfway between the third radius and the fourth radius. Fourth circle there. Then pi over 4 line, we're at 0.71, so that's a little bit underneath the third line, because that third line was at 0.75. Pi over 3, we're at 0.5, that's the second circle out there, and then at pi over 2, we were at 0, and this is starting to look kind of interesting as we start to connect the dots there. I think I know what's going to happen, but we'll plot the points just to be sure. Let me see if everybody's got that those first 5 dots plotted. And you can go and connect them with a nice smooth curve. Mariah, do you have some values here for those next 4 values? Cosine 2 pi over 3. Oh, I've got these right here, which is pretty easy.
These only have one chart. I want maybe one the other chart.
I'm sorry, say it again.
These only have one chart.
Yeah, they've got this one and this one. I have them working on. I just haven't crossed out all the negatives.
Okay.
So, Mariah, what do you have there for 2 pi over 3 cosine 2 pi over 3? Say again. Negative 0.5. Keep going. Okay. Anybody else? 3 pi over 4? Negative 0.71. 1.87. Negative 1. Okay, well this is going to be kind of weird. Okay, so 2 pi over 3. That's this angle right here. We have a negative 0.5. So remember, negative 0.5 means, so normally 0.5 would be right here, but 180 degrees opposite would be down here, right? Just along that same line, so we've got a dot right there. That's good. Negative 0.71, so on the 3 pi over 4 line, we normally would be, if it was a positive radius, we'd be up here, but it's a negative radius, which means go on that same line, but they're in that opposite quadrant. So, right there. At 5 pi over 6, we're at negative 0.87, so normally we'd be here, so we go to the opposite quadrant. And then at pi, we're at negative 1, which negative 1 means go a radius of 1, flip it back over here. And so, we have a nice circle there. Anybody wanna guess what's gonna happen as we run through these third and fourth quadrant dots? It's gonna do the same thing. That, 7 pi over 6 is gonna have a negative R value, so it's gonna put us here, then here, then here, then here, then here, then here. So it actually goes around again. And you end up with a circle that's there on the x-axis. It's kind of interesting if you think about it. The sine theta was, vertical, right, on the positive y-axis, the circle, and then the cosine was on the x-axis, just kind of like we're super familiar with. You can't immediately graph these on Desmos, but you can graph them kind of immediately on the calculator. So let's go ahead and just give that a try. We should have tabled this in the first place. Maybe some of y'all did. That's okay. Go ahead and grab your calculator, put it in polar mode, put it in radian mode, and let's go ahead and hit the y equals button, and let's try cosine theta. So go and put it in radian mode. So go radian mode and polar mode, everything's good. Then hit the y equals button, and let's just say r equals cosine theta. And the theta button, remember, is this one right next to the alphabet. What's that, parentheses? And let's grab it. You can grab it. Did you grab it? Well, yeah, see, it's a circle there, can't you see? No. You're plotting a series of points. I'm not sure what you're doing. Hit the y equals right there. The y equals. Nope. Delete. I want you to do cosine theta. R equals cosine theta. Mariah's closer. Is it giving you problems? Is there like a? Oh. Now why doesn't Jaws look like this? Saw. You zoomed in? Let's zoom in and let's see if that does anything. Do a zoom standard or zoom. Alright. Dominic, you deleted the equation. Let's do cosine theta. And then hit the graph, then zoom in. Zoom in. Enter. Oh, see, there we go. Let's go ahead and we need to reshape this so it's a zoom standard. Hit zoom. And then go down to zoom standard. That's gonna give you 10 by 10. Now we'll zoom in. So hit zoom and zoom in. And enter again. So actually zoom in. There, we can see that. Let's go ahead and zoom standard. Zoom standard is going to give you a negative 10 to positive 10, negative 10 to positive 10. I think you would enter twice because I'm seeing these little dots right up here. So hit the enter button again. When it finishes up here, now hit zoom, and zoom in. And hit enter again to actually zoom in. Okay. Zoom in. And hit enter again to zoom in. There we go. Now, y'all zoomed in, but I'm seeing more of an egg shape here, right? Yeah. And now, either it's right and we're wrong, or we're wrong, or we're right and it's wrong. Which one is it? Who's wrong? Us or the calculator? Is it a circle or is it an egg? Well, okay, then why is the calculator not showing a circle? Because your window's wrong. What's wrong with your window? It's not the steps. What's happened is, have y'all ever had, look up here real quick, have you ever had a picture, maybe it was something really nice that you copied from the internet and pasted into like Google Slides or Google Docs, something like that, and then you took it, and you took the corner, or you took an edge and you stretched it out this way, what happens to it? Yeah, like kind of gets stretched out like that, okay? So, if you look at your window settings, your y-axis is stretched out more than your x-axis. Click on zoom again, and this time let's go zoom square. That's gonna make everything, adjusted for the pixels.
Oh, a little bit. It still looks mushy.
It still does, okay, but that probably looks less like an egg. Mm-hmm. So do a zoom square, then maybe a zoom in, or zoom in and then a zoom square. It's a little better. If we were to increase the t-step or the theta step, then it would give us a lot more points and it would be more accurate. But we're still limited by the resolution of these calculators. I know you zoomed in too far. That's okay. I want you all to see that. Here in a minute, we'll actually use your MacBook and we'll get awesome, amazing circles. Okay, but not Desmos, because Desmos. That's fine. That's fine. Hit Y equals button. Cosine theta. Hit the mode. Real quick. Where in radian? Yep. Well, okay. Hit graph. So we can go back to. Oh yeah, that's fine. That's fine. Hit the zoom button. Oh, you have to quit out of there. Zoom. Go zoom standard. Yep. And then when this is finished thinking, zoom in. Zoom in. And then zoom standard. Zoom square. Alright, out and down the hall. Great sword, we go this way.